NVIDIA's OpenReasoning-Nemotron, advanced reasoning models for everyone. NVIDIA is shaking up the tech landscape by introducing its new suite of reasoning models, the OpenReasoning-Nemotron, which includes 4 distinct models boasting 1.5 billion, 7 billion, 14 billion, and 32 billion parameters. These models are derived from the powerhouse 671 billion parameter DeepSeek R10528 model. What's remarkable here is how NVIDIA has distilled this vast knowledge into 4 more manageable models based on Qwen 2.5 architecture. This means that even hobbyist gamers with standard setups can engage in advanced reasoning tasks without facing daunting GPU costs or over-reliance on cloud resources. The secret to this accessibility lies in the sheer volume of data used for training. By utilizing the NeMo skills pipeline, NVIDIA generated an impressive 5 million solutions spanning math, science, and coding challenges, and fine-tuned each model using only supervised learning techniques. Currently, the standout 32 billion parameter model has achieved impressive scores, an 89.2 on the IME 24 and a solid 73.8 on the HMNT February contest. Even the most compact model with 1.5 billion parameters managed commendable scores of 55.5 and 31.5, showcasing a range of capabilities despite its smaller size. NVIDIA sees immense potential in these models as a robust toolkit for research and experimentation. Enthusiasts and researchers will be able to download all 4 model checkpoints through Hugging Face, creating a valuable foundation for exploring reasoning driven by reinforcement learning, RL, or tailoring the models to more specialized applications. One particularly intriguing feature, Gen Select Mode, allows multiple iterations for each question, enabling users to generate several responses and select the best one. This functionality pushes the 32 billion model to deliver exceptional performance, potentially outpacing even OpenAI's high-performing models on numerous math and coding assessments. What's fascinating to note is that despite NVIDIA's models being trained solely through supervised fine-tuning, without reinforcement learning, they provide the community with pristine, state-of-the-art benchmarks to build upon for future RL initiatives. For gamers and tech enthusiasts who possess powerful gaming GPUs, this means having access to a model that closely approximates leading-edge performance, all while keeping computational processes local. New NVIDIA Llama Nemotron Super v1.5. Boost AI accuracy and efficiency. Imagine stepping into a world where artificial intelligence assistants are not just smarter, but also more efficient, capable of handling complex tasks with ease. Today, we're unveiling NVIDIA Llama Nemotron Super v1.5, a groundbreaking update that pushes the boundaries of what AI can achieve. But here's where it gets really exciting. This new version not only enhances performance, but also maintains the same level of computational efficiency, making it a game changer for developers and users alike. NVIDIA Nemotron, part of the broader NVIDIA AI ecosystem, is built upon the most robust open source models available today. By integrating advanced techniques and leveraging NVIDIA's open synthetic datasets, the team at NVIDIA has managed to significantly improve accuracy, efficiency, and transparency. This ensures that the AI models are not only powerful, but also reliable. Introducing NVIDIA Llama Nemotron Super v1.5, the latest iteration designed specifically for reasoning and agentic tasks such as mathematics, scientific problem solving, coding, function calls, following instructions, and even engaging in conversation. This version delivers substantial improvements across these core areas without compromising on speed or resource usage. What sets Llama Nemotron Super v1.5 apart is its enhanced reasoning capabilities. Built on the same solid foundation as Llama Nemotron Ultra, this model has undergone further refinement through post-training using a specialized dataset tailored for high-signal reasoning tasks. In benchmark tests spanning various domains, Llama Nemotron Super v1.5 consistently outperforms other models in its category, especially when it comes to tasks requiring multi-step reasoning and the use of structured tools. To ensure optimal performance and deployment, NVIDIA employed advanced pruning techniques, including neural architecture search. These methods increased throughput, allowing the model to process information more quickly and tackle more intricate problems within the same computational and time constraints. This means that stronger reasoning abilities at lower cost and the added benefit of running on a single GPU, significantly reducing computational overhead. Ready to see Llama Nemotron Super v1.5 in action? You can experience it firsthand at build.nvidia.com, https build.nvidia.com, NVIDIA Llama 3 Nemotron Super, 49B version 1.5, or download the model directly from Hugging Face, https huggingface.co, NVIDIA Llama 3 Nemotron Super, 49B version 1.5. And this is the part most people miss, the potential impact of such advancements. As AI continues to evolve, models like Llama Nemotron Super v1.5 pave the way for more intelligent applications across industries. But what do you think? How could these enhancements transform your work or daily life? Share your thoughts in the comments below. NVIDIA unveils OpenReasoning-Nemotron, tiny but mighty AI models for math and code. NVIDIA AI has just released OpenReasoning-Nemotron, a suite of large language models, LLMs, that excel in complex reasoning tasks. This release is a game changer, making state-of-the-art SOTA performance accessible to all. But here's where it gets controversial. Some argue that distilling models from a massive 671 billion parameter model could compromise their reasoning abilities. What do you think? The OpenReasoning-Nemotron suite includes 1.5 billion, 7 billion, 14 billion, and 32 billion parameter versions, all distilled from the 671B DeepSeek R1 0528 model. This distillation process prioritizes reasoning generalization, enabling these compact models to perform effectively on structured, high-cognition tasks. And this is the part most people miss. The training data is a thoughtfully curated subset of the DeepSeek R1 0528 dataset, emphasizing mathematics, science, and programming languages. These models set new SOTA Pass-1 scores for their size class across multiple reasoning benchmarks. Using generative selection with 64 candidates, GenSelect, performance improves even further, especially at 32B. This demonstrates strong emergent reasoning performance at scale. But is this level of performance necessary for most real-world applications? All 4 OpenReasoning-Nemotron models are released under an open and commercially permissive license, with model cards, evaluation scripts, and inference-ready weights available on Hugging Face. They're designed to plug into the NVIDIA NeMo framework and support various tool chains, facilitating rapid deployment in production and research settings. Key use cases include math tutors, scientific QA agents, code generation assistants, and more. In conclusion, NVIDIA's OpenReasoning-Nemotron models offer a pragmatic, open-source path towards scaling reasoning ability without frontier-scale compute costs. They provide a compelling foundation for developers, researchers, and enterprises working on logic-intensive AI applications. But the question remains, do the benefits of open-source accessibility outweigh potential compromises in reasoning ability? Let us know what you think in the comments.